The reaction between excess magnesium hydroxide, a slightly soluble base, and nitric acid occurs in aqueous solution, where it produces magnesium nitrate, a soluble salt, and water, according to the following balanced chemical equation. 0,05 dm cubed of the MgOH2 solution has a concentration 0,115 moles per dm cubed and is added to 0,025 dm cubed of a 0,095 moles per dm cubed HNO3 solution. Calculate the pH of the final solution. This is worth 10 marks. Now, an acid-base question like this, I call an incomplete neutralization. And that's because there is something that is in excess. Now, the general procedure of solving a question like this is as follows. First, we want to figure out whether the acid or the base is in excess. Now, in this case, they're telling us that the Mg or the magnesium hydroxide is in excess. So that makes our life a little bit easier. So if the acid is in excess, then the pH at the end is going to be less than 7. If the base is in excess, then the pH at the end is going to be greater than 7. So in this case, since we know magnesium hydroxide is a base, the answer we get at the end should be greater than 7. The next thing we need to do is we need to figure out the number of moles that's in excess. So we need to know what is in excess. Then the number of moles in excess. So this is going to be either, again, the acid or the base. After calculating the number of moles that's in excess, we need to calculate the number of moles of OH minus if the base is in excess, or H plus if the acid is in excess by dissociation. After calculating the number of moles of the OH minus or H plus, we need to calculate the concentration of the OH minus or the H plus. And here we need to look out for something called additive volume. After that, we may need to use the KW equation to calculate the concentration of H3O plus if we have the concentration of OH minus. And then the last step is to calculate the pH. Now this is just a general step, general guideline to the process of solving a question like this. It's not always going to be this way, but it's more or less how you would solve it. So let's start. We go to the top here. They tell us that the magnesium hydroxide is in excess, so that makes our life a little bit easier. So what we should start with is we know that the base is going to be in excess. We know that the base is in excess here, and what we need is to calculate the number of moles that's in excess. So to calculate the number of moles that's in excess, we need to calculate the number of moles of each thing at the start. So for magnesium hydroxide, we can calculate number of moles as C times V. The concentration is 0,115 multiplied by the volume 0,05, and that is equal to 0,00575 moles. Then the HNO3, the number of moles is equal to concentration times volume. So the concentration is 0,095 multiplied by the volume 0,025. And that gives us an answer of 0,002375 moles. of acid. Now, to calculate the number of moles that is in excess, we first need to work out how much of magnesium hydroxide do we need. So to do that, we'll do a mole ratio. So HNO3 to MgOH2. So the ratio from the reaction is 2 to 1. If we have 0,002375 and we need X, we can cross multiply. So 0,002375 equals 2X. That means X is equal to 0,001875, and this is moles of the base that we need. So this is how much we have, and this is how much we need. So to calculate the excess moles, it's going to be 0,00575 minus 0,001875, and that means we have 0,0045625 moles of the base left over. So we've calculated the number of moles that's in excess. So that's done, and that's done. Now we need to calculate the moles of the OH minus or the H plus by dissociation. Since the base is in excess, we need to work out the OH minus. So let's look at the dissociation. So I'm going to call this 0.2. So let's do it here on the side. So MgOH2 will dissociate into Mg2 plus ions and 2 OH minus ions. Now we can use a mole ratio here, but if we have 0,0045625 moles here, then if the ratio here is 1 to 2, that means this amount is going to be double that. So this will be 0,09125. So basically 2 times 0,0045625. So now we calculated the number of moles of OH minus that's in excess. Right? So this is the moles that we're working with now. And step number 3 is we want to figure out the concentration of the OH plus or the OH minus or H plus, and we need to look out for something called additive volume. So what is additive volume? So remember at the start, the container was empty, and they added in here 0,05 dm cubed of our base. Then they added in 0,025 dm cubed of our acid. Now our OH minus is in here. It's in this total volume. Right? So our OH minus is in here. So the volume that the OH minus is occupying is going to be 0,025 plus 0,05, which is 0,075 dm cubed. So to calculate the concentration, and this is of the OH minus, it's going to be the number of moles divided by volume. Number of moles we worked out as 0,09125 divided by the volume, which is 0,075, and that gives us a concentration of 0,12167 moles per dm cubed. Now we have the concentration. We can use the Kw equation to get the concentration of H3O plus. And why do we need to do this? Because remember, pH is equal to minus log the concentration of H3O plus, not OH minus. So step number 4 here, we'll say Kw is equal to the concentration of H3O plus times the concentration of OH minus. Now if we want H3O plus, we just substitute and solve. So 1 times 10 to the minus 14 is equal to the concentration of H3O plus and then multiplied by 0,12167. That means the concentration of H3O plus is going to equal 8,22 times 10 to the minus 14 moles per dm cubed. So now we have the concentration of H3O plus. And then the last step is calculate the pH. So step number 5, the pH is equal to minus log the concentration of H3O plus. Now we substitute, so minus log 8,22 times 10 to the negative 14, and that gives us an answer of 13,09.